Hey everyone, welcome to Tutoring. Hope you're having a great day today. We'll be doing a question submitted to me by a student, and that is Chapter 2E, Question 7. So we'll be moving back to vectors. And more specifically, this will be on your collinearity topic, but this question has pretty much everything, all the concepts related to vectors. So it's good for a quick revision, and it's also good if you're struggling with this question. So let's get into the question. Question 7. In triangle OAB, we've got vectors OA, which is 3i plus 4k. And then you've got a three-dimensional vector OB, which is I plus 2j minus 2k. Well, if you encounter, any of these vector questions, the first thing you should be doing is usually sketch or get a diagram up, right? So let's get an idea of what it looks like first, and then we'll answer the question. So we've got point O, the origin, moving to A, wherever it is. You don't have to be, you don't have to be accurate on what 3i plus 4k looks like. Just get a vector and just label it. So OA, we call that 3i plus 4k. So that's what the vector is. And then you've got vector OB, which in this case is I plus 2j minus 2k. Once again, you don't need to know where it is, but if you read ahead of the question, it says angle AOB. So A to O and then to B is an obtuse. So, something bigger than 90 degrees. So just get a rough sketch, maybe somewhere here. So that is an obtuse angle, and vector OB is I plus 2j minus 2k. Okay, so we've got a diagram. That's good. Let's start solving the question. So part A says use a scalar product to show that angle AOB is an obtuse angle. So that is saying that this angle right here, I'll call it theta, is bigger than 90 degrees. Well, we've got a formula for vectors that allows us to find theta, right? And that formula, I'll do part A at the bottom, is cos theta equals to one vector, the dot product of two vectors, divided by its magnitudes, right? In this case, if you want to find theta, it's the dot product of these two vectors, OA and OB. Make sure it's tail to tail. What I mean by that is make sure it's OA and OB and not OA and BO, because OA and BO would give you this instead, because BO is going the other way, and that gives you this angle, not that angle, right? So it'll give you this angle right here, which is what we don't need, okay? So be careful. Make sure it's OA and OB, so tail to tail. So OA, I'll just write it here, dot with OB, and of course we divide it by the multiple of their magnitudes. So OB right there. Let's do some quick maths here. OA, what is OA? That is 3i plus 4k. And then what is OB? OB is I plus 2j minus 2k. And we divide it by their magnitude, right? So OA, magnitude of that is the square root of their coefficient square. So 3 square is 9, and then plus 4 square is 16, multiplied by the magnitude of OB, which is 1 square plus 2 square, which is 4 plus another 2 square. And if you were to do the math here, 3. So when you find the dot product of two vectors, hopefully we know how to do this, but that's multiply the coefficient of your respective vectors. So 3 multiplied by 1 for I, and we get 3. And then 4 multiplied by negative 2 for k, we get negative 8. And then there's a 0j in here. 0j, of course, 0 times 2 is 0, so you can just ignore that. And the magnitude, 9 plus 16, that would be 25. Square root of 25 is 5. And then multiplied by square root of 9, which is a total here, and that's 3. What we get is 3 minus 8 is negative 5. Negative 5 divided by 5 times 3, that's negative 1 on 3. So that's what cos theta is, okay? And of course, if you want to solve for theta, that would be the cos inverse of negative 1 on 3. But there is a problem. What is cos inverse of negative 1 on 3? We haven't learned that, right? We haven't learned that yet, right? If this was a tech-free question, you can't use a calculator, we can't do anything. But what you can think of is, okay, let's look at what cos is on the unit circle. As we know, the unit circle has a system of CAST, so C-A-S-T. Cos is positive in the first quadrant and the fourth quadrant, but it is negative on the second and the third quadrant. And what can we see here? Well, you have a negative number, so that means cos theta or theta is in quadrant number 2 or quadrant number 3. So you can technically say, actually I'll write it down, the working out that you should be saying is cos theta is less than 0, because we know that for sure. Cos theta is less than 0 implies that theta is bigger than 90 degrees, right? Because if your theta is in one of these quadrants, that's definitely bigger than 90 degrees already, right? So that means that angle AOB is an obtuse angle, right? Is an obtuse angle, and there we go. So that's how you prove part A. And if you're probably wondering, okay, what happens if it's bigger than 180 degrees? Wouldn't that be, you know, like a reflex angle? But if you think about the range of a cos inverse, what do you know about the range of cos inverse x? It is between 0 and pi, right? So you can immediately ignore all these two the bottom two quadrants. You can only talk about these two quadrants because that's 0 all the way till pi, right? Okay, and that means you can of course only pick first or second quadrant. We know it's negative, so therefore it has to be the second quadrant. So therefore it's between 90 and 180 degrees. It's an obtuse angle. You can just write this and it's implied in your answer, okay? That's part A, all done. Let's move on to part B, the more interesting part. So part B says find OP, so the vector OP where P is, so that's a point, is the midpoint of AB. So let's look at where AB is first. What is the vector AB? Well, that's just joining A and B together, right? That's it, simple as that. A to B, and we want to find the point P, so that is the midpoint of AB. Okay, how would you go about that? Well, they literally just asked us find OP, so we'll just write that down. OP, how do you go from O to P? So how would you go there? If you want to go from O to P, then you go O to A and then A to P. So taking a detour, O to A plus A to P. We know that OA, in this scenario, let's have a look here. Actually, I'll write it down here. OA is 3i plus 4k, right? But what we have is with AP is, we know P is halfway between AB. So you can write this as half multiplied by AB, right? So actually I'll write it here so you can see it. OA plus half of AB. And then of course half of AB is, here's a quick tip, A to B would be O to B minus O to A. So it's origin to the second letter minus origin to the first letter. That's it. So let's take a look. What is OB? Fill it in. I plus 2j minus 2k, and then minus vector OA, so that's minus 3i and then minus 4k, because the minus applies to both. So minus 3i minus 4k, and that's half of AB. So let's do some maths. 3i plus 4k, can't touch that just yet. We'll leave the half in there. I, so this I right here, and then minus 3i, that's minus 2i, and then you've got 2j by itself, don't do anything to that, so plus 2j, and then minus 2k minus 4k, that is minus 6k. And then now you can expand the half out. So what we get is 3i plus 4k, I'll do this quickly, minus I plus j, and then minus 3k. And then we add them together. So we get 3i minus I, that is 2i. And then of course you have the plus j by itself, so that's plus j, and then plus k, so that's 4k minus 3k, and that is your vector OP. So that's part B, okay, or part BI, so where P is the midpoint, and that's what you get for your vector. Let's move on to double I.